Hello there, and welcome back to another quiet night of sleepy science. Tonight, we are going to spend a few slow hours with something that has been in front of your eyes your entire life. Literally in front of them. The human nose. It sounds like a small subject. It is not. The nose is the doorway your body has kept open since your first second of life, and it will still be open on your last. It is a heater, a filter, a chemistry laboratory, an alarm system, a memory library, and a piece of evidence about where your ancestors lived and what kind of air they had to breathe. It is also the part of the face that painters ruin, that sculptors break, that emperors cut off, that poets mock, and that almost nobody thinks about until it stops working. Sometimes the nose protects you without asking. Sometimes it lies to you. And sometimes it quietly hands your brain a memory from 30 years ago, complete, unedited, and warm. In this video, we will look at the nerve that touches your brain more directly than any other sense you own. The caves behind your cheeks that nobody has ever fully explained. The emperor who had his nose cut off and took an empire back anyway. The astronomer who wore a false one for 35 years and the metal it turned out to be made of. The disease that erased noses across Europe for 300 years. The cold air that shaped human faces over thousands of years and may still be shaping yours. And the quiet machinery running a few centimeters from your eyes right now without ever asking your permission. If you enjoy these calm journeys, you are welcome to like, subscribe, or leave a quiet thought below. But for now, none of that matters. All you need to do is settle in. Let your shoulders drop away from your ears. Let the room get a little softer around you. Notice, if you like, the small, cool feeling of air moving into you and the slightly warmer feeling of it moving out. That is the whole subject of tonight, happening on its own, without any effort from you at all. And as the day begins to fade, join me while we explore this quiet world together. Let's begin. Of all the primates on Earth, only one has a nose that sticks out from its face. And you are it. Look at a chimpanzee, a gorilla, an orangutan, a baboon, a lemur. Their nostrils open more or less flat against the front of the head. There is no bridge, no tip, no projecting structure standing out into the air. Then look at any human being from any part of the world, of any ancestry, and there it is. A small tent of cartilage pitched in front of the skull. It is one of the very few pieces of anatomy that is unmistakably and exclusively human, more reliably so than the chin, more so than the shape of the ear, more so than almost anything above the neck. If a stranger from somewhere else were handed a shelf of primate skulls and asked to find ours, the nasal opening would give us away long before the brain size did. We like to think of our species as defined by intelligence, and we say so at every opportunity. But if you were describing us honestly to somebody who had never seen one of us, working only from the outside, the first sentence might well be, "They are the ape with the nose." The olfactory bulb is the one place where your brain reaches out and touches the outside world almost directly. Above the roof of your nose is a thin plate of bone with tiny holes drilled through it, and through those holes pass the fibers of your smell neurons, straight up into a structure sitting on the underside of the brain. There is no relay, there is no translation, no conversion, no intermediate device. The cell that touches the molecule is connected to the brain by its own body, its own single thread. Every other sense involves layers of machinery standing between the world and the mind, translating and retranslating. But smell is a nerve ending sitting in the open air with the brain on the other end of it. When you breathe in a room, the room is, in a very literal sense, arriving at your brain. That thin plate of bone has a name, the cribriform plate, and it is riddled with holes because it has to be, which makes it one of the most fragile pieces of the entire skull. It is a compromise that nobody would choose if they were offered an alternative. To let the world touch the brain at all, there has to be a gap left in the wall. Every design has one place where the armor is thinner than everywhere else, and in a human being, that place is directly above the nose. It is the shortest distance between the world and you, and it is about the width of a coin. Smell is the only sense that does not report to the thalamus first, and that changes everything about how it feels. Sight, sound, and touch all pass through the thalamus, a kind of central switchboard buried in the middle of the brain, before they reach the regions that make sense of them and hand them to you. Smell skips it entirely. Signals from the nose go almost immediately into the amygdala, which is deeply involved in emotion, and the hippocampus, which is central to memory. The path to the parts of the brain that produce careful, conscious description is longer and less direct, and it arrives late. This single anatomical detail explains almost everything odd about smell. Why it hits you before you can name it. Why it feels rather than informs. Why a smell can flood you with a mood you cannot account for and did not choose and cannot argue with. It also explains something that people rarely say out loud. You can dislike a place instantly on walking into it, for no reason you could produce if challenged, and be entirely right. You can meet a stranger and feel something arrive ahead of any thought about them. Some of that is nonsense, and some of it is the smell system doing exactly what it was built to do, delivering a verdict straight to the emotional machinery, several seconds before the reasoning machinery has even been handed the file. The other senses come in through the front office and wait to be announced. Smell has a key to the back door. This is why a single smell can return a memory more completely than a photograph ever will. Everyone knows the story of the writer and the small cake dipped in tea, and how the taste and the smell together opened a childhood he thought he had lost for good. What is remarkable is that the science eventually caught up with the novel. Studies comparing memories triggered by smells with memories triggered by words or pictures tend to find that the smell-triggered ones are older, more emotional, and much more likely to make a person feel as though they are back inside the moment rather than looking at it from outside. A photograph shows you the past, framed and at a distance. A smell puts you in it with no warning and no frame at all. Nobody has to teach anyone this. There is no preparing for it either, which is the cruel part and possibly also the kind part. A photograph can be approached carefully. You can decide to look at it on a Tuesday when you feel able. A smell arrives while you are reaching for something else entirely, in a hurry, thinking about the shopping, and the whole of a person is suddenly in the room at full strength. And then it fades, and you are standing in a hallway holding a coat, and the house is quiet again. Everyone who has ever opened a drawer belonging to someone who died already knows it, and knew it within about half a second. Smell is the only sense that will not wake you, and this is one of the strangest facts about the human night. A sound wakes you, a light wakes you, a touch on the shoulder wakes you instantly, even a light one. A smell, in general, does not. Once a sleeper has descended past the lighter stages, the smell system appears to go remarkably quiet, and research has found that people can sleep straight through odors strong enough to be genuinely unpleasant while awake. This is why smoke alarms exist, and it is why they had to be invented at all. Almost every danger in human history announced itself with a noise or a movement, and we kept a guard posted on those doors, all night, every night, for 1,000,000 years. Fire announces itself with a smell first, and there was nobody watching that particular entrance. It is an odd gap in an otherwise careful design, and it may exist simply because the smell system has no route through the thalamus, which is the structure most involved in deciding what is allowed to reach you while you sleep. The back door that lets memories in so easily is, at night, unstaffed. So you are lying there now, breathing, sampling the room, taking in absolutely everything, and none of it is being reported to anyone. Every other sense keeps a night shift. The ears go on listening and will pull you out of the deepest sleep for your own name spoken quietly across a room. The skin will wake you for a draft, for a change in the weight of a blanket. The nose keeps working perfectly, gathering everything, sorting everything, and reports none of it to anybody until morning, when you wake and smell the house and find it exactly as it was. The information was there all night. Nobody was collecting it. The nose does not close, it just stops calling. Around 3/4 of what you think is the taste of your food is actually smell. Your tongue is a limited instrument. It detects sweet, sour, salt, bitter, and savory, and that is close to the whole of the list. Everything else, the entire difference between a strawberry and a raspberry, coffee and chocolate, lamb and beef, a good tomato and a bad one, arrives through the back of your throat and up into your nose while you chew. This is called retronasal smell, and it is why food goes flat and gray during a cold, and why people who lose their sense of smell almost always say they have lost their sense of taste. They have not. Their tongue works perfectly well and always did. It is simply that flavor was mostly a nose event all along, being quietly credited to the mouth because that is where the chewing was happening. It also explains why the food of childhood can never quite be reproduced. People chase it for decades, hunting the recipe, blaming the ingredients, insisting that tomatoes used to taste of something. Some of that is true, and most of it is the fact that flavor was never only ever in the food. It was in the nose of a child, which was newer and more sensitive than the one asking the question now. It was in a house with its own particular smell. It was in a body that was hungry in a way an adult body has forgotten how to be. You have been misattributing your dinners your entire life. Your smell nerve cells are the only neurons in your body that are routinely replaced throughout your entire life. Most of your nervous system is built once and then defended. The neurons you have at 25 are largely the neurons you will die with. But the sensing cells in your nose are exposed directly to the outside world, to smoke and dust and cold and infection and everything else that comes through the door, and they simply do not survive long under those conditions. So the tissue keeps a supply of stem cells sitting beneath the surface, and it replaces the sensing neurons every month or two, over and over, for as long as you are alive. Every single one of the new cells has to grow a delicate fiber up through a plate of bone and find the exactly correct place to connect in the brain, without a map, in the dark. It works. It has been working in you this entire time. Consider what that would mean anywhere else in you. If the cells carrying your vision were replaced every 6 weeks, you would expect the picture to shift, to blur, to need relearning, the way a new pair of glasses does for a fortnight. It does not happen with smell. The tissue is torn down and rebuilt continuously, and the smell of your own kitchen is identical to what it was last year and the year before. Somehow, the new cells keep finding the old addresses, and nobody fully understands how they manage it. There is a part of your nervous system that quietly rebuilds itself while you sleep and never asks you to learn anything again. The two sides of your nose take turns, and one of them is always doing more work than the other. This is called the nasal cycle, and once you know it exists, you can feel it. Over a period of a few hours, the tissue in one nostril swells slightly, and the airflow through it drops, while the other opens up and takes the load. Then, without any announcement, they swap. Most people go their entire lives without noticing, because the total amount of air arriving stays the same, only the balance shifts. Nobody is completely certain why the body does this. One idea is that it gives each side a chance to rest and rebuild its moist lining, which is doing hard work in dirty air. Another is that it improves smelling, because fast-moving air and slow-moving air reveal different kinds of odor molecules, and a nose running both at once misses less. Whatever the reason, there is a slow rhythm moving through your face all day and all night, changing sides while you are busy with other things. If you would like to check, cover one nostril and breathe, then the other, and compare them. One will be noticeably freer than the other, almost always. If you did the same thing in 3 hours, the answer would probably have reversed. Nothing will have happened in between. Nobody will have done anything. The tide simply went out on one side and came in on the other, the way it always has, on a schedule that belongs entirely to you and that you have never once been consulted about. You have a tide in your head. It is turning now. Roughly 10,000 liters of air pass through the average adult nose every single day. That is not a poetic figure. It is just arithmetic. A resting adult moves something in the region of 6 to 8 liters of air per minute, and most of it goes through the nose rather than the mouth. Multiply across a day, and you get a volume that would comfortably fill a small bedroom. All of it heated, all of it moistened, all of it filtered, and all of it handled by a piece of you roughly the size of a plum. If you sat down and tried to consciously condition 10,000 liters of air to that standard, you would need machinery, electricity, filters, a water supply, and a maintenance schedule. And it would be noisy, and it would break. Your face does it silently while you sleep, while you argue, while you forget entirely that it exists. And it does all of it without a filter to change, without a part to replace, without a single day of downtime across 80 years. The nearest thing we have ever built to it is a machine that needs a technician twice a year and still cannot manage the smell of a room. It never occurred to anybody to be impressed by this because the specification was met long before any of us arrived, and a thing that has always worked is invisible. Some of the most impressive engineering in your body is the part you use to hold up your glasses. Behind your face are 4 pairs of hollow caves, and nobody is entirely sure what they are for. The sinuses. 2 behind the forehead, 2 behind the cheeks, 2 between the eyes, and 2 deep at the back near the base of the skull, in a place you would need a surgeon to reach. They are air-filled, lined with the same tissue as the nose, and drained by openings so small they seem almost designed to cause trouble later. The honest position of science is that we do not know why they exist. Perhaps they lighten the skull. Perhaps they add resonance to the voice. Perhaps they humidify air or act as crumple zones protecting the brain from a blow to the face, or are simply leftover space where bone never bothered to grow because there was nothing asking it to. Every explanation has a good objection waiting for it. It is a strange thing to sit with on a quiet night. You have caves in your head. They have been there your whole life, and the reason is still an open question. The pattern of your frontal sinuses is unique, and it has been used to identify people. The scalloped upper edges of the sinuses behind the forehead form a shape as individual as a fingerprint, and remarkably, it differs even between identical twins who share everything else. Because they are enclosed in bone, they survive fire, water, and decay far better than soft tissue does. Forensic scientists have used comparisons between an old head X-ray taken in life and the skull of an unidentified person to establish who someone was when nothing else remained to go on. It is a quiet and slightly haunting fact. There is a signature written inside your forehead, drawn in empty space rather than ink, that you will never see, that nobody has ever looked at, that has been there since your teens, and that would still be perfectly legible long after everything else about you had gone. The most famous artificial nose in history belonged to an astronomer, and it was not made of gold. Tycho Brahe lost part of his nose in a duel with a fellow student in 1566, reportedly over a dispute about a point of mathematics, which is a very specific way to lose a piece of your face. For the rest of his life, he wore a prosthesis, and the legend held that it was made of gold and silver, and the legend was repeated for 400 years by everyone who told the story. In 2010, researchers examined material recovered from his remains and found that the metal was brass. There is something perfect about that correction, and something rather kind. The greatest observational astronomer of his age, the man who measured the positions of the heavens more precisely than anyone had before telescopes existed, spent 4 centuries being credited with a nose made of gold. And it turned out to be a cheaper metal, colored carefully to look right in candlelight. Even the man who cataloged the stars was, in the end, doing his best with what he had. Your nose is the only part of your face that has its own skeleton, and most of that skeleton is not bone. Only the top third of the nose is made of bone. It is a small bridge formed by 2 thin plates that meet in the middle, tucked between the eye sockets, and it is not much bigger than a fingernail. Everything below that, the part that gives your face its profile, the part that people notice from across a room, is cartilage. Firm, springy, slightly translucent material that bends and returns. This is why a nose can take a knock that would crack a cheekbone and simply flex out of the way. It is also why the shape changes so easily under a finger, and why a sleeping face pressed into a pillow looks briefly like someone else's when it lifts. The design is not an accident. A rigid nose standing at the front of the head would be a liability in almost every fall a body ever takes, and bodies take a great many falls before they learn not to. A flexible one is a small shock absorber standing exactly where the damage arrives first. There is a small experiment you can run without moving. Press the very tip of your nose gently sideways and feel how far it travels. Then run a finger up towards the bridge until you reach the place where it stops giving way. That boundary, somewhere around the middle, is where cartilage becomes bone. It is the border between two entirely different materials sitting in the middle of your face, and most people find it for the first time somewhere in their 40s by accident and are mildly surprised. You are carrying a soft door in a hard doorway. It has been holding up remarkably well. The Sphinx is missing its nose, and it was not Napoleon. The story is everywhere, and it is very satisfying. French soldiers, cannon fire, an act of casual vandalism during the Egyptian campaign. It cannot possibly be right. Drawings made by a European traveler decades before Napoleon was even born already show the Sphinx without its nose, sitting in the sand exactly as it sits today. The more likely explanation comes from a medieval account describing a man who was angered by people making agricultural offerings to the statue and who damaged its face for religious reasons, and who was reportedly executed for it in the 14th century. Whether that specific story is accurate in every detail is uncertain, but the timing fits, and the Napoleon version simply does not. What is certain is that a stone nose survived 4,000 years of desert wind and did not survive people, and that the blame has been sitting on the wrong army for 2 centuries, because a better story always travels faster than a true one. Air moving into your nose is warmed almost to body temperature before it reaches your throat. Think about what that means on a winter morning. You step outside into air that might be near freezing or well below it. Within a distance of roughly 10 centimeters, in less time than it takes to finish the breath, that air arrives at the back of your throat close to the temperature of your own blood. The lungs are delicate and they do not tolerate cold well at all. So the nose acts as a small radiator lined with a dense network of blood vessels sitting just beneath a thin, wet surface, giving away heat as fast as the air can steal it, and then replacing that heat from the blood, breath after breath, without interruption. Nothing about this is optional, and nothing about it is conscious. On the coldest night of the year, standing outside in a coat, watching your own breath appear in front of you, you are running a heating system with no switch and no thermostat that you have never once had to maintain. It has been running since the day you were born. You have never noticed a single adjustment it made. The same air is also humidified on the way in, from whatever it was outside to almost fully saturated. Dry air damages lung tissue, so the nose does not only heat the air, it waters it. The lining releases moisture continuously, turning desert air, aeroplane air, radiator air into something soft enough for the lungs to accept without complaint. On a dry day, a person can lose a surprising amount of water this way and never notice. Exhaled invisibly, breath after breath, all day. This is part of why a long flight leaves you feeling strangely parched, no matter how much you drink, and why a heated bedroom in winter can leave your throat rough by morning. The nose was giving away water all night to protect the tissue further down, and by 4 in the morning, it was running low. It asks for nothing back. It simply keeps the inside of you at the humidity of a warm, damp cave, no matter what kind of weather is standing outside the window, no matter what month it is, no matter where in the world you have chosen to live. When someone lies, the tip of their nose changes temperature very slightly, and this has actually been measured. Researchers using thermal imaging cameras found that when people performed a mentally effortful deception, the temperature around the nose tended to drop a little while the forehead warmed, apparently reflecting changes in blood flow associated with concentration and stress. It is subtle, it is not reliable enough to convict anybody of anything, and the researchers themselves were careful to say so, repeatedly, to journalists who did not want to hear it. But they called it the Pinocchio effect, because of course they did, and because there is something genuinely wonderful about the fact that a story invented for children in the 19th century turns out to be gesturing, by pure accident, at something faintly real. The nose does not grow when you lie, it cools. Nobody in the room can see it happen, but a camera can, and it did. Inside each side of your nose are curled shelves of bone called turbinates, and they are the reason the whole system works. If you could look inside, you would not find an open tube, you would find scrolls. 3 curved shelves of paper-thin bone on each side, wrapped in soft, wet tissue, hanging into the airway like waves frozen in the middle of breaking. Their purpose is surface area. By folding the walls of a small space into curls, the nose creates an enormous amount of warm, wet surface without needing an enormous amount of room. Air cannot slip straight through. It has to swirl, brush past tissue, slow down, give up its dust, and take on heat and water, whether it wants to or not. The whole cathedral of it is packed behind the bridge of your nose, in a space you could cover with 2 fingers, and most people live and die without ever seeing a picture of it. Evolution rarely builds elegant things on purpose. It simply keeps whatever survived the winter. This survived every winter there was. The largest nose ever officially measured on a living person is about 8.5 centimeters long, and there is a much wilder story that nobody can verify. The record recognized by Guinness belongs to a man from Turkey whose nose measured a little under 9 centimeters from bridge to tip, and the photographs are genuinely striking. Behind that stands a far stranger claim from much longer ago. A traveling performer in 18th century England is said to have had a nose of around 19 centimeters, appearing before audiences as a curiosity, and that figure has been repeated in print for 200 years. The evidence is an old illustration and an old written account, and historians treat it with considerable caution for the obvious reason. It may be true, it may equally be exaggeration by people selling tickets to a show. It is one of those small holes in the historical record where something genuinely remarkable might have happened, and nobody at the time thought to measure it properly, and now nobody ever can. Your nose produces around 1 liter of mucus a day, and you swallow almost all of it. This is one of those facts people wish they had not learned, so let me make it kinder. Mucus is not waste. It is the working fluid of the entire system. It is mostly water, with long proteins that make it sticky and stretchy in a very particular way. And it is the surface on which everything is caught. Dust, pollen, smoke, bacteria, fragments of the world, the small pieces of every room you have ever walked into, all of it lands in the mucus instead of your lungs. That sheet of fluid is constantly being moved backwards, swallowed, dissolved by stomach acid, and replaced from underneath, all day, all night, whether you are awake for it or not. You are not producing slime. You are running a conveyor belt with a disposal furnace at the far end of it. When you are healthy, you never notice it once in 70 years. You only ever meet your mucus on the days it fails. The mucus is moved by millions of microscopic hairs beating in coordinated waves. They are called cilia, and each cell in your airway lining carries hundreds of them. They are impossibly small, and they do not beat randomly. They beat in rhythm, in waves that travel across the tissue like wind moving over a field of wheat, always pushing in the same direction, always towards the back. The sheet of mucus rides on top of them like a raft and travels towards the throat at a speed of a few millimeters per minute. Slow, relentless, never stopping. It runs while you are asleep. It runs while you are under anesthetic in an operating theater. It ran through every hour of every year you have ever lived, and it is running right now while you lie still and listen to a stranger's voice. If you have ever stood at the edge of a field and watched a slow wind cross it, you have seen what the inside of your nose looks like at this moment, in the dark, doing its work with no audience at all. Cold air and cigarette smoke both slow those hairs down, and that is why they make you ill. The cilia are sensitive things. When air gets very cold, or when smoke coats them, their rhythm slows and the mucus sheet stops moving properly. Whatever landed in it simply stays where it fell, sitting on tissue instead of leaving. This is one of the reasons researchers think respiratory infections rise in winter, and one of the reasons a person who smokes coughs in the morning. The cough is doing manually and violently what the cilia stopped doing automatically and gently. It is a small mechanical fact with an enormous consequence, and it quietly explains something you have felt your whole life without ever knowing the mechanism behind it. The conveyor belt did not break. Nothing dramatic happened. It just got cold and slow, and the things it was carrying sat down where they were. The smell of rain has a name, and you can detect one of its ingredients at concentrations that would embarrass a shark. The word is petrichor, coined in the 1960s to describe the scent that rises when rain falls onto dry ground. Part of it is oils that plants have shed onto the soil during dry weather, thrown into the air when water strikes them. And part of it is geosmin, a compound made by bacteria living in the soil, released when they are disturbed. The human nose is extraordinarily sensitive to geosmin, able to detect it at a few parts per trillion, which is a level of sensitivity roughly comparable to a shark detecting blood in water. Nobody knows exactly why we should be so finely tuned to it. It might be that finding damp earth and water mattered enormously to our ancestors in a dry season, and that the ones who noticed it first lived. The sensitivity is genuinely absurd once you put a number on it. A few parts per trillion is the equivalent of noticing a single drop in an enormous swimming pool, and noticing it instantly, from a distance, through an open window, while thinking about something else entirely. There are laboratory instruments that struggle with that. Yours arrived free, requires no calibration, has never been serviced, and has been sitting quietly above your top lip your entire life, waiting for it to rain. Whatever the reason, on the first evening of rain after a long dry spell, when everyone steps outside and says the same thing about the air, every one of them is detecting a bacterial molecule at a concentration too small to imagine and calling it a lovely evening. The mucus in your nose is chemically hostile, and it is fighting things all night. It contains lysozyme, an enzyme that breaks apart the walls of bacteria. It contains defensins, small proteins that puncture microbes. It contains antibodies, immune cells, and proteins that bind up metals in order to starve invaders of the iron they need to grow. The wetness on the inside of your nostril is not neutral. It is a carefully maintained chemical environment that is genuinely difficult to live in. Most of what lands there dies quietly, gets swept backwards, gets swallowed, and is never mentioned again by anyone. You will never know about the overwhelming majority of the threats your body has handled on your behalf, because they were dealt with at the door, in the dark, in a fluid you have spent your entire life being faintly embarrassed by. There is a war being fought for you every night, and it has never once woken you up to tell you about it. The visible hairs in your nostril are a coarse first filter, and they have a proper name. They are called vibrissae, and they sit right at the entrance where the air first arrives. They are not delicate and they are not decorative. They catch the big things. Insects, ash, grit, seeds, fragments of the world that have no business anywhere near a lung. Behind them, the finer work is done by mucus and cilia, but the hairs are the outer gate, and they are the reason nothing large ever gets past. It is a two-stage filter, coarse first and fine second, exactly the way an engineer would design it if you gave them the problem and a year to think about it. And it was arrived at by nothing but survival and time. There is something quietly funny about it. One of the least admired features of the human face, trimmed in bathrooms all over the world every morning, is a piece of protective equipment that works perfectly. When you breathe through your nose, your body produces a gas that helps your lungs work better. The lining of your sinuses releases nitric oxide, a small and very reactive molecule, and it travels down with the air you inhale. In the lungs, it helps relax the blood vessels around the tiny air sacs, which improve the transfer of oxygen into your blood. Breathe through your mouth, and you skip that step completely. This is one of several reasons researchers have become interested in nasal breathing, and it is a good example of how the nose is not simply a hole in a face. It is adding something to the air, not just cleaning it. It is not a filter, it is a small factory that happens to be on the way in. Your face has been dosing your own lungs with a helpful gas on every single breath you have ever taken for your entire life, and it has never once mentioned it to you. Your nose deliberately makes breathing harder, and that is part of the design. The nose accounts for roughly half of the total resistance in your entire airway. On paper, that looks like a mistake. Why build a bottleneck into the front of the system, right where the air comes in? But the resistance is useful. It slows the air down, giving the heating and the humidifying more time to do their work. It also creates a slight back pressure that helps keep the small air sacs in the lungs gently open rather than collapsing at the end of each breath. Mouth breathing is easier and worse, which is a sentence that could describe half the decisions in a human life. This is one of the elegant, counterintuitive things that bodies do. Sometimes the friction is the feature. Something in you decided long before you existed, long before anyone existed who could have explained it, that the air should have to earn its way in. A sneeze is not just an exhale. It is a coordinated reflex that involves your whole upper body. It begins with an irritation, sends a signal along the trigeminal nerve into a region of the brainstem, and comes back as a sequence in order every time. Deep breath in, vocal cords close, chest and abdominal muscles contract hard against the closed door. Then the door opens. Your eyes close, which is not optional and cannot be overridden by wanting it, and the pressure releases in a burst through the nose and mouth. The whole performance is organized somewhere below the level of your awareness, in a part of the brain that has never needed your permission for anything. You cannot properly sneeze on purpose. You cannot easily stop one once it has committed. For a fraction of a second, an old and unsentimental piece of your brainstem takes the controls of your body away from you, cleans the doorway, and hands them back without explanation or apology. The old figure for sneeze speed is almost certainly wrong, and the truth is more interesting. For decades, people repeated that a sneeze travels at 100 miles an hour. Careful high-speed filming, notably work done at MIT, found that the air itself is considerably slower than that. But the same research found something far more surprising. A sneeze is not a spray of separate droplets flying through a room. It is a turbulent gas cloud that carries its droplets inside it, and that cloud can travel much further than anyone had expected, several meters in some cases, because the droplets are not traveling alone and are not slowing down the way an isolated droplet would. They are being carried by a small weather system that they created. It changed how scientists think about the air in enclosed spaces. A sneeze is not a shot fired across a room. It is a puff of private climate, leaving your face and drifting. Somewhere between 1 in 5 and 1 in 3 people sneeze when they look at bright light, and it runs in families. It is called the photic sneeze reflex, and it has an unusually pleasing acronym, ACHOO, standing for Autosomal Dominant Compelling Helio-Ophthalmic Outburst, which sounds like a joke made by someone who is very tired and is in fact a genuine medical term. Walk out of a dark cinema into afternoon sun, and some people sneeze reliably every time, and have done since childhood. The best guess involves a crossing of signals. The nerve carrying information from the eye and the nerve carrying irritation from the nose run close together. And in some people, a strong flash of light appears to bleed across into the sneeze pathway. It is inherited, and roughly half the children of a photic sneezer will have it. It does nothing useful, it fixes nothing, protects nothing, and warns of nothing. It is simply a small wiring quirk that has been passed down through families for countless generations, sneezing at the sun. Your sinuses are not fully built when you are born. They grow into you. A newborn has only small hints of the spaces that will eventually exist. The cavities behind the cheeks are barely there. The ones behind the forehead are essentially absent altogether. Over childhood and then into the teenage years, they hollow out and expand slowly. And this is part of why a child's face and an adult's face are shaped so differently, and why photographs of a person at 9 and at 19 can be so hard to reconcile. The face does not simply enlarge, it excavates. Some people never develop frontal sinuses at all and go through an entire life perfectly normally without ever finding out. The architecture of your own skull was still under construction while you were learning to read, and it finished quietly without telling you, sometime around the age you first thought of yourself as grown. Your sinuses hurt on aeroplanes because of a physics problem with a very small door. The openings that drain each sinus are narrow, and when a plane climbs or descends, the pressure outside your head changes faster than air can move through those openings to keep up. The gas in the cave is then at the wrong pressure relative to the world, and it presses outward or pulls inward against the lining, which is richly supplied with nerves and has strong opinions about being stretched. If you have a cold and the openings are already swollen almost shut, that mismatch can become genuinely severe, which is why cabin crew take it seriously. It is not the altitude hurting you, it is not the flying. It is the simple fact that you are carrying sealed rooms inside your face, and somebody changed the weather outside them faster than the doors could cope with. Your nose and your eyes are connected by a small tube, which is why crying makes your nose run. At the inner corner of each eye is a tiny opening leading into the nasolacrimal duct, a narrow drain running down through bone into the nasal cavity. Tears are made continuously, spread across the eye with every blink, and disappear down this pipe into the nose, where they join the mucus and get swallowed with everything else. Most of the time, this is entirely invisible, and you would never guess it was happening. But when tear production rises, the drain overflows into the nose faster than the nose can process it, and it comes out of the front. So you cry, and then you sniff, and then you need a tissue, and the tissue is catching tears that took the long way round through your skull. Grief and a runny nose are connected by plumbing. It has always felt like poetry. It turns out to be anatomy. Lying on your side blocks the lower nostril, and this happens to almost everyone. The tissue inside the nose is spongy and full of blood vessels, and like everything full of blood, it responds to gravity. Lie on your left side, and blood pools slightly in the left side of the nasal lining. The tissue swells, and that nostril quietly narrows. Roll over, and within a few minutes, the situation reverses, and the side that was open closes, while the side that was closed opens. Anyone who has lain awake at 2 in the morning with one blocked nostril, turned over in irritation, and felt it clear while the other side shut down, has run this experiment properly and drawn the wrong conclusion from it. It is not imagination. It is not an illness. It is not the pillow. It is simply soft, wet tissue obeying gravity in the dark while you try to fall asleep, and it has been doing this every night of your life. A blocked nose changes your voice, and every language on earth uses this on purpose. When you say the sound or n, you are deliberately letting air resonate up into your nasal cavity, using the space in your face as part of the instrument. Block the nose, and those sounds collapse, which is exactly why a person with a heavy cold says, "My dose is blocked," rather than "my nose is blocked," and why the joke is the same in every country. Some languages go a great deal further than this. French and Portuguese have nasal vowels, whole sounds that exist only because the passage into the nose is deliberately left open while the vowel is spoken, and speakers do it thousands of times a day without any idea that they are doing it. There are people who have spent decades learning a language and never once realized that a piece of the pronunciation lives in a cavity behind their own eyes. Your nose can only smell things that are dissolved, so a completely dry nose smells nothing. Odor molecules floating in air cannot be detected directly by anything. They must first land, then dissolve into the thin layer of mucus covering the sensing tissue, and only then can they reach the receptors waiting underneath. This is why smell fades when the nose is very dry, on an aeroplane or in a heated room in February. And it is why the humidifying job and the smelling job are not two separate systems, but the same wet surface doing two things at the same time. Every scent you have ever experienced in your life, every one of them without exception, was something that dissolved in a film of fluid inside your head before your brain ever knew it existed. The perfume, the bread, the rain, your mother's coat. This is also why the world smells stronger in the minute after rain, and why a dog's nose is wet, and why the first thing anyone ever does with a flower is bring it close enough that the air between them turns warm and damp. It is not romance, it is solubility. The molecule has to land in water before anything at all can happen. And every rapturous description ever written about a scent is, underneath all of it, a description of something dissolving. There is no smelling in a dry world. Wetness is a precondition for wonder. The sensing part of your nose is smaller than a postage stamp, and it is right at the top. Most of your nasal cavity is plumbing and air conditioning. The actual smelling happens in a small patch of tissue high up in the roof of each side, only a few square centimeters in total, tucked away in a corner where the airflow mostly does not go. This is why a gentle breath tells you less than a short, sharp sniff. Sniffing changes the pattern of airflow entirely and throws more air upwards into the sensing zone. It is a deliberate act, and it is why everyone in the world does it the same way. When a person leans towards a glass of wine, or the top of a baby's head, or a coat that belonged to someone who is gone, and takes that small, sharp breath in, they are aiming air at a patch of tissue the size of a thumbprint at the top of their own skull. Everything that follows, all of it, every memory it opens, comes from there. You have around 400 different types of smell receptor, and each one is a lock waiting for a particular shape. Every receptor sits on the surface of a nerve cell, and it responds when a molecule of roughly the right shape and charge settles into it. No single receptor recognizes coffee. Instead, coffee contains hundreds of different molecules, and each of them tickles a different combination of receptors, and the pattern of that combination is what your brain reads as coffee. It is closer to a chord than a note. It is closer to a chord than most chords, in fact, because a piano has 88 keys and your nose has 400, and almost all of them are being pressed a little bit all the time. This is why smell is so hard to describe and so easy to recognize. You are not identifying an object, you are identifying a pattern across 400 channels, most of which have no name and never will have one. Ask someone to describe the smell of their grandmother's kitchen and they will fail, and then they will smell it 30 years later in a stranger's house and know it instantly, completely, before they have finished the breath. The recognition is perfect. The vocabulary was never built. Color has words. Red, blue, the whole shelf of them, agreed upon and taught to children before they can read. Sound has words and notation and centuries of theory built on top. Smell has almost nothing. Every language on earth borrows for it, saying that something smells like something else, passing the problem sideways rather than solving it. Only a handful of languages, mostly spoken by peoples who hunt, have genuine words for smells, the way the rest of us have words for colors. Everybody else describes the fridge by naming its contents. Your nose is fluent in a language your mouth was never taught. The genes for those receptors make up one of the largest gene families in your body, and half of them are broken. Humans carry something in the region of 800 smell receptor genes, which is an enormous number, more than we devote to almost anything else we do. But roughly half of them no longer work. They are pseudogenes, still sitting there in the sequence, still perfectly readable, simply no longer switched on. They are the ruins of receptors our ancestors had and we no longer use. Nobody has to clear them away because evolution does not tidy up after itself. It just stops maintaining a thing and lets the weather get in. So you are walking around with several hundred sets of instructions for detecting smells that no living human being has ever detected, written out in full, filed carefully, and never opened again by anyone. Which raises a question that nobody can answer. What were they? What did an ancestor of yours walk into a clearing and notice immediately, without effort, that you would now walk straight through and find perfectly empty? The information is not recoverable. The genes are there, but the experience is not, because an experience needs a living receptor and a brain expecting the signal. Whatever it was ordinary to them. It was simply what a morning smelled like. Somewhere inside you is a library of things your family stopped being able to notice, generation by generation, without anyone deciding to. And every one of the books is still on the shelf, in the dark, in perfect condition. The discovery of how smell works was recent enough that the scientists who found it are still remembered by name. For most of the 20th century, nobody knew how the nose actually detected odors. There were theories, and some of them were quite strange, including one suggesting that molecules were identified by their vibration rather than their shape. It was only in 1991 that Linda Buck and Richard Axel described the family of receptor genes and showed how the system was organized, and they received a Nobel Prize for it in 2004. That is astonishingly late. We had split the atom, sequenced genes, built computers, and walked on the moon before we understood what happens when you smell bread. It is worth sitting with for a moment on a quiet night because it says something about us. Your grandparents were adults before anyone knew. Every perfume composed before 1991, every wine described by an expert, every confident claim made about scent in the entire history of the species up to that year was made by people who had no idea what was happening inside their own heads when they breathed in. They were not wrong about the experience, they simply had no idea where it came from. The knowledge is younger than most of the furniture in an average house. The most emotionally powerful sense you own, the one that reaches furthest back into your own life, was, in scientific terms, a complete mystery until almost the day before yesterday. One well-known study estimated that humans can distinguish more than 1 trillion different smells, and the number is still argued about. The research, published in 2014, mixed odor molecules into complex blends and tested how well people could tell them apart, then scaled the result mathematically to estimate the total. The figure they arrived at was around 1 trillion, which is far, far higher than anyone had assumed. Almost immediately, other scientists pushed back, arguing that the mathematics stretched too far beyond the actual data, and that argument has never fully closed. The honest summary is that the true number is unknown, and that the disagreement itself revealed something quietly embarrassing. We had never really measured it at all. We had simply repeated an old guess of 10,000 for decades because someone once wrote it down and nobody checked. There is something worth noticing in the story itself, quite apart from the number. A figure was invented, written down, printed, taught, repeated, cited, and believed for the better part of a century. And it was never anything more than somebody's rough guess on an ordinary afternoon. Science does correct itself eventually, but it corrects slowly and only when somebody finally bothers to look again at the thing everyone had already agreed on. Most of what everybody knows has never actually been checked by anybody. What we can say with real confidence is that human smell is vastly richer than the textbooks used to claim, and that nobody yet knows where its edges are. Hold your nose while eating an apple and an onion, and it becomes hard to tell them apart. It is an old party trick, and the reason it survives as a party trick is that it works. Without the smell channel, both are just sweet, wet, crunchy, and faintly sharp, and people genuinely hesitate. The moment you release your nose, the onion arrives all at once, with full force, and everybody laughs. What is strange is that almost nobody believes this until they have done it themselves. The sense that flavor lives on the tongue is extraordinarily persistent because the tongue is where the pressure and the texture and the temperature are all happening, and the brain places the whole experience where the touch is. It is a location error. It is universal, it happens to everyone, and it lasts a lifetime. And the misfiling is not sloppiness, it is useful. A creature needs to know whether the thing in its mouth is safe immediately, as one single verdict, not as two separate reports from two departments requiring assembly and interpretation. So the brain fuses them before you ever see the result and hands you a finished object called flavor, with no seams anywhere in it and no indication of where any part of it came from. You are given the conclusion. You are never shown the evidence. Your brain has been filing your nose's reports under your tongue's name since childhood, and nobody has ever corrected the paperwork. Some of what you think you are smelling is not smell at all, but a nerve that reports pain. The cool of menthol, the burn of chili, the sharpness of ammonia, the prickle of a fizzy drink at the back of your nose. None of these are detected by the smell system. They are detected by the trigeminal nerve, the same nerve that carries touch and pain from your face, which also has endings scattered throughout the inside of your nose. It responds to irritation, temperature, and pressure, and it does not care what molecule caused them. So the fresh cold of peppermint is not a smell any more than a paper cut is a color. It is a chemical touching a pain nerve, and the nerve saying cold, because cold is the only word it has for that sensation. This is why a person with no sense of smell whatsoever can still enjoy a curry, still flinch from ammonia, and still find peppermint refreshing. The pain nerve is untouched by any of it. It is why menthol seems to work in a blocked nose when nothing else does, and why a very hot chili hurts in exactly the way an injury hurts. Because as far as that nerve is concerned, it is an injury, and it has no way at all of telling the difference. Half of what you file under scent is actually your face being gently interfered with, and you have been calling it perfume. The idea that humans have a poor sense of smell may be one of the longest-running mistakes in science. The belief traces back largely to a 19th century French anatomist who noticed that the smell-related regions of the human brain take up a smaller fraction of the whole than they do in other animals, and concluded that we had traded smell for intellect. It was an argument about proportion, not about ability, and it hardened into an accepted fact through nothing but repetition, passed from textbook to textbook for over a century without anyone re-examining the original reasoning. Modern work has challenged it thoroughly. The human olfactory bulb contains a number of neurons broadly comparable to that of many other mammals. In absolute terms, our smelling equipment is not small at all. It only looks small when it is standing next to an unusually large brain. The claim survived because it was flattering and because it explained something that everybody wanted explained. We're the thinking animal, the story went, and the price of thought was the nose, and on the whole, the trade was worth it. It is a very tidy story. It is also exactly the kind of story that stops people from measuring, because once a fact explains why you are special, checking it starts to feel faintly like bad manners. A century of research went missing inside a compliment. We spent 100 years believing we were bad at something, largely because we were rather pleased about being good at something else. In one experiment, people were able to follow a scent trail across a field, on their hands and knees, like a dog. The researchers laid a line of chocolate essential oil through grass, blindfolded their volunteers, put ear protection on them so they could not orient themselves by sound, and asked them to track it. Most of them could. They zigzagged from side to side, exactly as a dog does, casting across the trail to find its edges and correct their course. And with a few days of practice, they got measurably faster and more accurate at it. Not as good as a dog, but not in an entirely different category either, which is not what anybody expected. The people had never been taught how to do it. Nobody explained the zigzag. The ability was already installed, unused, sitting quietly under decades of never once needing it. Somewhere underneath your ordinary daily life is a tracking animal that has simply never been asked. You smell in stereo, and your two nostrils do not receive the same information. Your nostrils are far enough apart, and the airflow through them differs enough that the two sides of your nose sample the world slightly differently at every moment. Research suggests the brain can use the comparison between them in the same way it uses the difference between your two ears to work out where a sound is coming from. It is subtle, and nobody is walking around consciously triangulating the smell of a bakery. But the machinery is there, and it appears to contribute to the sense of direction that makes trail following possible at all. 2 eyes gave you depth, and everyone knows it. 2 ears gave you space, and everyone knows that too. 2 nostrils gave you something much quieter and much older, and we are only now beginning to find the words for it. Because one nostril usually runs faster than the other, each side is better at different smells. This is a genuinely elegant discovery. Some odor molecules stick to the nasal lining readily, and they are detected best in slow-moving air because slow air gives them time to land. Others are reluctant to stick, and they are detected best in fast-moving air because fast air simply brings more of them past. Since the nasal cycle keeps one side fast and one side slow at all times, and then slowly swaps them over the course of a few hours, your nose is always running 2 different sampling strategies at once and rotating them steadily through the day and the night. It is not a flaw that one nostril feels blocked. It is coverage. Your face is running 2 experiments simultaneously all your life and has never told you the results of either. Your nose stops reporting a smell after a few minutes, even though the smell is still there. It is called adaptation, and it happens quickly. Walk into a bakery, and for the first 30 seconds it is overwhelming, almost too much. Stay for 10 minutes, and it is simply gone. The molecules have not left the room. Your receptors have adjusted and stopped signaling about something that is not changing, because a signal that never varies carries no information. The nose is not built to tell you what is present. It is built to tell you what is new. This is why a gas leak is so dangerous, why perfume gets reapplied a little too heavily by people who can no longer detect it, and why someone who smokes cannot smell smoke in their own coat. The nose is a difference detector wearing the costume of a description machine, and it has fooled everyone. Which is why your home has a smell that everyone can detect except you. Every house smells. Of the people, the cooking, the fabric, the damp or the dryness, the soap, the animals, the age of the walls, the last 20 winters. Visitors notice it within the first second of stepping through the door, and then adapt within a minute and forget it entirely. You have never noticed it at all, not once, because you have been adapted to it since the day you moved in. If you go away for 2 weeks and come home and open the door, you will get 1 single second of it, 1 clear breath before the system shuts it off again for another year. That 1 second is the closest you will ever come to smelling your own life from the outside. It is the same reason you cannot smell yourself, and the same reason that everybody else can. There is no unkindness anywhere in it. It is only physics and habit. For the first months of life, a human baby can only breathe through its nose and cannot easily switch. Newborns are what physiologists call obligate nasal breathers. The anatomy of a very young throat sits high, with the soft palate and the larynx close together, which allows an infant to breathe and feed at the same time without choking. A genuinely useful arrangement when your entire job is to feed for 20 minutes without pausing. The cost is that the mouth is not really available as an airway. A blocked nose in a newborn is therefore not a minor irritation. It is a serious problem, which is why every parent of a small baby ends up standing in a bathroom at 3 in the morning running hot taps. Over the first few months, the throat gradually lengthens and drops. The 2 paths separate, and the option of mouth breathing arrives quietly, along with the ability to make a much wider range of sounds. It is a small trade, made in the first year, and every person who has ever spoken a word made it. To learn to talk, we had to give up breathing and eating at the same time. Newborn babies find the breast partly by smell before they can see much of anything. A newborn's vision is poor, and their world is a soft blur of light and shape and movement. But their nose works from the first minute. Studies have found that infants placed on the mother's body will move preferentially towards the scent of the breast, and that the secretions of the skin around it appear to attract them without anyone showing them anything. Within a few days, a baby can reliably distinguish the smell of its own mother from the smell of another. It is one of the first pieces of knowledge a human being ever acquires, arriving before language, before faces, before memory in any form we would recognize as memory. The very first thing many of us ever learned was a scent, and not one of us can remember learning it. And mothers can identify their own baby by smell within hours of birth. The experiments are simple and rather moving. Give a mother several sleep suits, only one of which was worn by her own infant, and she can usually pick it out, sometimes after only a very short period of contact with the child, and very often while insisting she has absolutely no idea how she is doing it. The knowledge is real and the confidence is low, which is the common signature of the smell system in almost everything it does. Fathers can frequently do it as well, so can grandparents and siblings. The information passes into you without asking permission and settles somewhere you cannot reach with words. You know things about the people you love that you could never say out loud, And some of that knowledge is not sentiment at all, it is chemistry. There is an organ in your nose that detects pheromones in many animals, and in humans it appears to be a ruin. It is called the vomeronasal organ, and in mice and snakes and a great many mammals, it is a genuine, working second nose devoted entirely to social chemistry. In humans, there is often a small pit in roughly the same place, visible if you look for it. But the nerve that would carry its signal anywhere is usually absent in adults, and the genes for its receptors are largely broken. The current scientific position is that it probably does nothing at all. This matters because it is the honest answer to a question that people very much want a different answer to. Human pheromones are sold, advertised, and confidently discussed by people with something to sell. The evidence that any specific human pheromone exists is, to this day, thin. It is a beautiful example of the world being less magical and considerably more interesting than the story about it. Some studies suggest people find the natural scent of others more or less pleasant depending on immune genes. But this work is more delicate than it is usually reported. The famous experiment asked women to smell shirts worn by men and rate them, and found a tendency to prefer the scent of men whose immune system genes differed from their own, which in theory might favor more varied immunity in any children. It is a wonderful result, and it has been repeated with mixed success, some studies supporting it and others not, with the effect being small and easily swamped by everything else that determines who a person happens to like. It belongs in the category of intriguing and unsettled rather than established, and anyone who tells you otherwise is going further than the data does. But it does point at something real underneath. Your skin is producing information about you continuously, all day, and other people's noses are reading it, quietly, without anyone involved ever deciding to. Losing your sense of smell is far more devastating than people expect, and it went unrecognized for a long time. Anosmia is the medical name for it. Until recently, it was often treated as a minor complaint, a small inconvenience sitting somewhere far below blindness or deafness on any list worth making. The people who lost it described something else entirely. Food becomes fuel. Cooking becomes guesswork. The smell of your partner, your children, your home, your own body, all gone at once, and with them a whole layer of emotional connection to the world that nobody had realized was there until it vanished. Many describe a specific and hard-to-explain grief that other people struggle to take seriously. There is now much better understanding of this, gained the hard way and at an enormous scale in recent years. It turned out that the sense we took least seriously was quietly carrying a great deal of what we meant by feeling at home. Some people are born without any sense of smell at all, and often do not realize for years. Congenital anosmia is rare, but it exists, and the striking thing about it is how late it tends to be discovered. If you have never smelled anything, there is no absence to notice. Children learn the word smell, learn that other people use it constantly, and quietly assume it must mean something vaguer than it does, some subtle thing everyone else is being a bit poetic about. Many find out in adolescence or much later, sometimes in the middle of a single strange conversation with a friend that suddenly goes wrong. In some cases, it accompanies a condition affecting the development of certain nerve pathways, and in others, it stands entirely alone with no explanation. It is a quiet reminder that you cannot miss a sense you never had, and that no one can tell you what your own experience is failing to include. Some people smell things that are not there, and it is called phantasmia. The classic report is smoke or burning or something rotten arriving out of nowhere in a room where nothing is burning and nothing is rotten, sometimes for weeks. It can follow a head injury, an infection, a migraine, or nothing identifiable at all. Related to it is parosmia, in which real smells arrive distorted so that coffee becomes chemical and food becomes genuinely intolerable. And this became far more widely discussed in recent years than it ever had been before. Both tell you something important about how smell is made. The pattern of receptor signals is a code, and the brain is decoding it. And a code with damaged pieces in it does not produce nothing. It produces something wrong confidently. The smell is really happening. It is just happening a little further in than usual. Smells can enter your dreams even though they will not wake you. Sleep researchers have introduced odors to sleeping volunteers and then woken them afterwards to ask what they had been experiencing. Pleasant smells, in some studies, were associated with more pleasantly toned dreams, and unpleasant ones with the opposite. The smell rarely appears in the dream as a smell. It seems instead to tint the whole thing, to shift the weather of it, the way a change in the temperature of a room might, without ever announcing itself as the cause. This makes a great deal of sense given where the signal goes. It arrives beside the emotional machinery rather than the descriptive machinery, so it never becomes an object in the story. It becomes the mood of the story. There is something quietly touching about that. A room can change what you feel while you sleep in it, without ever appearing in the film you are showing yourself. This may be part of why sleeping in an unfamiliar room feels different in a way that people struggle to name, beyond the pillow and the noise and the light under the door. A hotel has a smell. A hospital has a smell that nobody ever forgets. A childhood bedroom, visited decades later, has a smell that has somehow survived new paint and new owners and 30 years. None of it reaches you as information. All of it reaches you as atmosphere, which is precisely the material that dreams are built out of. Something in the air of wherever you are tonight is being folded into whatever you are about to imagine. And in the morning, you will remember the dream and not the reason for it. In one line of research, a smell present while learning and again during sleep improved what people remembered. The idea is called targeted memory reactivation, and the experiment is elegant. Volunteers learned a task in a room scented with something distinctive, roses in the original study. Later, while they slept, the same scent was quietly released into the room around them. Those who received it during deep sleep tended to remember the task better the next day, and brain recordings suggested that memory-related regions were more active at the moment the scent arrived. The scent seemed to act as a cue, nudging the sleeping brain to rehearse something it had already filed away. The effect is real but modest, and researchers are still working out its limits, so this is not a trick to reorganize your life around, and it is not a promise of anything. But the principle alone is remarkable enough. Your memory can be gently reminded of something while you are entirely unconscious. Not by a voice, not by a hand on your shoulder, by a smell, drifting through a dark room, finding a brain that is not awake, but is still, in its own quiet way, listening. There was a disease that quietly erased noses across Europe for 300 years, and it worked from the inside out. Untreated syphilis, in its late stage, could produce masses of inflamed tissue that destroyed cartilage and bone from within. And one of the places this happened most visibly was the septum, the wall in the middle of the nose. When the support went, the bridge collapsed inward, producing what clinicians still call a saddle nose. It was slow. It took years, sometimes decades, arriving long after the person had stopped thinking about the illness that caused it. And because there was no treatment worth the name until the 20th century, the result was simply part of the ordinary street, in every city, for generation after generation. There is a reason so much of the history of nose surgery is concentrated in exactly those centuries. The demand was enormous, and it was permanent. What ended it was not a better surgeon. It was penicillin, arriving in the middle of the 20th century and quietly closing a chapter that had been open since the 15th, and taking with it a face that everybody in Europe had grown used to seeing. Smell fades with age, usually so gradually that people do not notice it happening. The decline generally begins somewhere in middle age and becomes considerably more common after the age of 60 or so, and by the later decades, a substantial proportion of people have measurable loss. Very few of them know about it. Because the change is slow, and because smell is not something anyone tests unless there is a reason, the world simply becomes gently quieter without any announcement being made anywhere. Food gets less interesting, cooking gets saltier. Older people are sometimes accused of over-seasoning by their children, and this is exactly why. And the accusation is a little unkind. The tissue thins, the replacement of the sensing neurons becomes less efficient than it was, and a lifetime of small damage adds up in a place that is exposed to everything. It is worth knowing about, not in order to be sad about it, but because it is one of the few losses that can be measured, noticed, and worked around rather than quietly accepted as a vagueness that arrived with the years. There is a chemical that some people find repulsive, others find pleasant, and others cannot smell at all, and the difference is written in a single gene. The compound is androstenone, found in human sweat and, famously, in pork. Present it to a room full of people and you will get 3 completely different answers. To some, it smells strongly of urine and sweat and is genuinely unpleasant. To others, it is faintly sweet, vanilla-like, almost floral, and they cannot understand the fuss. And a third group simply cannot detect it at all and wonders what everybody else is talking about. Researchers traced much of that difference to variations in a single receptor gene. Change one small part of one lock, and the same key opens a different door, or no door at all. This is the closest most people will ever come to genuinely understanding that other people's worlds are not the same as theirs. It is worth following that thought one step further before it goes. If a single gene can do this with one molecule, and there are 400 receptors, and every person carries a slightly different set of them, then no 2 people in any room have ever been smelling quite the same room. Not approximately the same, not close enough to matter. Different. Every dinner table in history has been several different dinners, eaten at the same moment by people who assumed they were sharing one. It is not a difference of opinion about a smell, it is a different smell. 2 people can stand together in the same kitchen in the same second and be in measurably different rooms. The reason some people say coriander tastes of soap is that, for them, it does. The leaf that most of the world calls coriander and North America calls cilantro contains aldehyde compounds that are chemically related to those found in some soaps and detergents. Most people register the fresh, citrus, green part of the plant and enjoy it, and never notice the rest. But some people carry a variation near a smell receptor gene that makes them unusually sensitive to those particular aldehydes. And for them, the soap note dominates everything else in the dish and cannot be ignored. It is not fussiness. It is not a failure of sophistication. It is not culture, although culture certainly affects how much of it a person will tolerate politely. It is a receptor difference producing a genuinely different experience of the same leaf. There is a small and rather gentle lesson buried in it that goes well beyond herbs. When someone says a thing tastes wrong to them and everyone else at the table disagrees, it is entirely possible that every single person there is telling the truth. Asparagus produces a smell in the urine of almost everyone, but only some people can detect it, and that is 2 separate genetic lotteries. This is a favorite of researchers because it is unusually clean and unusually easy to test. The vegetable contains a sulfur compound that the body breaks down within a remarkably short time, sometimes within minutes, and the products of that breakdown are volatile and highly distinctive. For a long time, people assumed the split in the population was between those who produce the smell and those who do not. It turned out that the more important split is between those who can smell it and those who cannot, and that ability appears to be linked to variation near a cluster of smell receptor genes. So there are households in which one person is puzzled and mildly outraged, and the other is entirely oblivious, and both of them are correct, and neither can ever prove anything to the other. It is a very small mystery, but it has been quietly dividing families for as long as anyone has been growing the stuff. Some people can smell illness, and at least one of them changed how a disease is studied. A Scottish nurse noticed that her husband's smell had changed years before he was diagnosed with Parkinson's disease. Later, meeting other people with the condition at a support group, she recognized the same odor in the room again and realized what she had been noticing. When she mentioned it to researchers, the reasonable and expected response would have been polite skepticism followed by nothing. Instead, they tested her. She was given worn t-shirts, some from people with the condition and some not, and she identified them with remarkable accuracy, including one shirt she insisted was positive when the records said it was a control. That person was diagnosed sometime afterwards. Considerable work has since gone into identifying exactly which compounds she was detecting, with the aim of building a test that does not require her. What makes it better is how nearly it did not happen at all. She had noticed the change for years and said nothing, because there was nothing sensible to say, and no way of saying it that did not sound strange. It took a chance remark at a public talk, made almost in passing. If she had stayed quiet that evening, as most people would have, the entire line of research would not exist, and nobody would ever have known there was anything there to find. It is one of the loveliest stories in modern science, because it began with somebody saying something that sounded impossible, and somebody else deciding to check anyway. Dogs can be trained to detect certain diseases by smell, and the interesting part is what that tells us about bodies. Trained dogs have been studied for their ability to detect various conditions from breath, urine, or skin, with results that vary considerably by study and by condition, and researchers remain careful about how far the claims should be pushed. But the underlying principle is not in doubt at all. A body that is doing something unusual is producing an unusual chemistry, and that chemistry leaks out. It comes off the skin, out of the lungs, into the air of the room, continuously. Illness has a smell. It has always had a smell in every century, and physicians used to be trained specifically to notice it, sniffing at breath and at wounds, long before there were machines to do the noticing for them. Somewhere in this is a quiet argument that the nose was a diagnostic instrument we retired a little too early and a little too confidently. The smell of freshly cut grass is a plant's distress signal, and we have decided it is the smell of summer. When grass is torn, it releases a family of compounds known as green leaf volatiles. Their functions appear to include limiting damage at the wound and, in some cases, signaling in ways that may attract the insects that prey on the things eating the plant. In other words, it is an alarm. It is a field calling for help. We have built our entire cultural image of a peaceful summer afternoon out of the sound of plants shouting, and we find it deeply relaxing. There is nothing tragic in this, because plants are not suffering in any sense we would recognize, and nothing in a lawn is having a bad day in the way that a person can. But it does rearrange the picture slightly and pleasantly. Every lawn mown on a Sunday morning is a chemical siren going off across a whole neighborhood, and every human being within range responds to it by feeling calm and thinking about lemonade. The smell of old books is the sound of paper slowly falling apart. Paper made from wood pulp contains lignin, and over decades, lignin breaks down, releasing a whole range of volatile compounds, among them substances chemically related to vanilla. Along with them come faint notes of grass, of almond, of something slightly acidic. Together, they make the specific scent that anyone who has walked into a secondhand bookshop recognizes instantly and cannot describe to anyone who has not. Chemists have analyzed it quite seriously, partly because the smell can indicate the chemical condition of an old volume, which means a conservator's nose is a genuine scientific instrument that happens to be attached to a person. The lovely, melancholy thing about it is what the smell actually means. The book is decaying. That scent is the sound of the object leaving, released slowly enough over enough decades that we have had time to fall in love with the sound of it going. Astronauts report that space has a smell, and it is waiting for them when they come back inside. There is no smell in a vacuum because there is nothing there to carry it, but something clings to the suits, the tools, the handrails, the inside of the airlock, and when the hatch is opened, it comes in with them. The descriptions are consistent enough to be strange. Burnt metal, seared steak, welding fumes, gunpowder. Different people, different missions, different decades, and very similar words every time. The best guess involves highly reactive forms of oxygen clinging to surfaces in vacuum, and then combining the instant they meet ordinary cabin air, along with the chemistry left behind by everything that has ever burned out there. It is not really the smell of space, so much as the smell of space touching us and reacting. Still, Every human being who has ever gone outside the door has come back in and reported the same thing about the air, and not one of them has been able to say it properly. The smell of the sea is largely a gas produced by dying microscopic plants. That clean, sharp, unmistakable seaside air is not salt because salt does not evaporate and has no smell at all. Much of it is dimethyl sulfide, produced when tiny ocean plankton are damaged or eaten and their internal chemistry breaks down and escapes. It drifts up out of the water and into the wind and travels for miles. Seabirds use it to find feeding grounds, following the scent across open ocean to the places where something is eating the plankton, and therefore to the places where there is food for them too. So the smell you associate with holidays and freedom and the first sight of the horizon from a car window is, in the language of the ocean, a signal that means something is being eaten here. It travels a long way too, which is why the sea announces itself before it appears. Anyone who grew up inland remembers the moment in a car journey when somebody opens a window and says it, and everybody agrees, and the water is still 20 minutes away behind a hill. There is nothing to see yet. The information arrived early, on the wind, carried in a molecule made by something far too small to see, breaking apart quietly somewhere out past the horizon. It is beautiful anyway, perhaps a little more so. Smell is the oldest sense, and almost everything alive has some version of it. Long before there were eyes, before there were ears, before there was a brain worth mentioning anywhere on the planet, there were single cells that could tell what chemicals were nearby and move accordingly. Towards food, away from poison. That is smell in its original form, and it is roughly as old as life itself. Bacteria do it, plants do it in their own slow way. Every animal you can think of does it, including the ones with no head. Vision is a newcomer by comparison, a recent and showy invention. When you lie in the dark and something in the air makes you feel, for no reason you could name if asked, safe or uneasy, you are using the oldest piece of equipment you own. It is also the sense we trust the least and the one that has been right for the longest. We build our courtrooms on eyewitnesses and our science on measurement, and both of those are recent inventions using recent equipment. The chemical sense has been keeping things alive continuously since before there were creatures with a front and a back. Every organism that ever survived long enough to have descendants did it partly by knowing what was in the water around it. It was working before there was anything at all to see with. It will very likely be the last part of the design that anyone ever manages to improve on. Breathing through your nose changes the electrical rhythm of your brain, and breathing through your mouth does not. This is one of the more startling findings of the last decade. Researchers recording brain activity found that the rhythm of nasal breathing was reflected in the activity of regions involved in memory and emotion, with the oscillations synchronizing to the breath itself, rising and falling with it. When the same people breathed through their mouths instead, the effect largely disappeared. The signal appears to originate in the sensing tissue of the nose, which responds to the mechanical flow of air across it, not only to odor. The nose is, among everything else it does, a sensor for its own airflow, and that sensor is wired directly into the deep brain. Which means the act of breathing in through your nose is not simply moving air from one place to another. It is a rhythmic tap on the door of the parts of you that remember and feel. Slow, steady, once every few seconds, for your entire life, including this one. In the same work, people recognized fearful faces faster when they happened to be breathing in through the nose. The effect was small and highly specific, and it only appeared during nasal inhalation. Breathe out or breathe through the mouth, and it faded away. Memory recall showed a similar pattern in the same experiments. The most reasonable interpretation is not that breathing gives anybody special powers, and the researchers were careful about this. It is that the brain's ongoing rhythms and its readiness to process information are subtly coupled to the breath, and that the nose is where the coupling happens. It is a very quiet finding with a very large implication sitting inside it. The thing you have been doing continuously since your first second of life, without once thinking about it, has been keeping time for you the whole while. Which puts a very old piece of advice in a slightly different light. When somebody says take a breath, they are usually telling you to calm down, and you usually resent it. But the instruction turns out to be describing a real mechanism rather than a manner of speaking. The breath is not a metaphor for composure. It appears to be genuinely connected to the machinery, and the connection runs through the nose, and it has been running through the nose the entire time you have been alive. And the metronome is in your face. This is part of why slow nasal breathing appears in almost every calming tradition ever invented in every part of the world independently. Nobody in ancient India or ancient China or the monasteries of medieval Europe knew anything about brain oscillations or nitric oxide or the trigeminal nerve. They knew only that if you breathe slowly through the nose and let the out-breath be long, something settles. So they wrote it down in different languages on different continents without contact over and over for thousands of years. It is one of the more convincing pieces of evidence in the entire history of human self-observation, precisely because nobody involved had a theory to defend. They just noticed and reported. This is not medical advice, and it is not a cure for anything. It is simply the observation that people have been finding the same small door for a very long time, and that when modern instruments were finally pointed at it, there did turn out to be something on the other side. At night, your nose runs its own quiet schedule, and part of it is why you wake up congested. The nasal cycle does not stop when you sleep. It carries on switching sides through the night, and it interacts with your position, with gravity, with the temperature of the room, with the dryness of the air from a radiator. Blood flow to the lining changes with the deep rhythms of the night, along with everything else in you. This is why the nose is so often at its worst in the first minutes of the morning, and improves within a few minutes of being upright and moving around. Nothing has gone wrong. Nothing is broken. The tissue is simply swollen after a night of lying still, and it drains as soon as you stand up. There is a whole small weather system running in your face that only operates while you are unconscious, and the only report you ever receive from it is the very first breath you take when you sit up on the edge of the bed. The nose knows when you are about to be ill before you do, and it changes what you want. When an infection begins, inflammatory signaling changes the state of the nasal lining, and smell often dulls before other symptoms arrive at all. Food loses its interest. Appetite drops away. Researchers have argued that this is not merely a side effect, but part of a coordinated response driven by the same set of signals that produce tiredness and withdrawal, and the strong desire to lie down under a blanket and be left alone. The body reduces the pull of the world so that you will stop moving around in it. Whether or not the full argument holds up, the observation itself is familiar to absolutely everybody. 2 days before you are willing to admit that you are getting ill, dinner quietly stops being appealing. That was not you deciding anything. That was chemistry turning down the volume on one of your senses so that you would go to bed. Anosmia can sometimes be trained back, slowly, and the method is astonishingly low-tech. Smell training involves sniffing a small set of distinct scents, typically something floral, something fruity, something aromatic, and something resinous, deliberately, twice a day, for months on end. The evidence suggests it can help some people recover some function after loss following an infection, and it is generally considered safe and inexpensive, which is a rare combination. It is not guaranteed, and it is not fast, and anyone dealing with smell loss should be talking to a clinician rather than to a video. But the reason it can work at all takes us back to something we have already met tonight. The sensing neurons regenerate. There is a tissue at the top of your nose that is still trying, still sending new fibers up through the bone month after month, still looking for a connection, whether or not anyone is paying attention. Smell training is not repairing anything. It is showing up and giving that tissue something to aim at. Nosebleeds almost always come from the same small patch, and it is a design compromise. At the front of the septum, the wall dividing the two sides of the nose, several arteries converge into a dense little web of vessels sitting immediately under a very thin membrane, close to the surface, close to the air. It is called Kieselbach's plexus, and it exists because the nose needs enormous blood flow near the surface in order to heat the air. The unavoidable consequence is that a knock, a dry winter, a hard sneeze, or a bored child's finger can open it very easily. It usually stops quickly and looks a great deal worse than it is, which is why it frightens people so reliably. The lesson is a general one about bodies, and it is worth carrying. Almost every vulnerability is the price of an ability. The nose bleeds easily because it is a radiator, and it is a radiator because you would very much rather not breathe January directly into your lungs. Your nose is deciding, right now, how much of the room to let in, and it has never asked your opinion. The lining swells and shrinks constantly, responding to temperature, to exercise, to emotion, to hormones, to what you ate, to whether you are lying down, to the time of day, to pollen, to the slow cycle running between the two sides. The width of the passage you are breathing through has changed several times since this sentence began, and it will change again before it ends. None of it was your decision, and none of it required your attention. This is true of most of you, of course, of the heart and the gut and the liver, but the nose is one of the rare places where you can actually feel the automatic machinery working if you go quiet enough to notice it. So lie still, breathe in. Somewhere just behind that is a system adjusting itself with great care on your behalf in the dark, and it will carry on doing exactly that long after you have stopped paying any attention to it tonight. Nobody is entirely certain why the human nose sticks out at all, and the leading explanations do not agree with each other. One idea is that the nose is essentially a leftover. As human faces flattened and jaws pulled back over evolutionary time, the soft tissue and cartilage around the nasal opening had nowhere to go and ended up standing proud of the face by default rather than by design. Another is that it is genuinely functional, that a long projecting passage buys extra distance in which to warm and moisten air, which would matter enormously for a species walking out of the tropics and into dry and cold places it had never seen. A third connects it to endurance running and heat, to a body that needed to move for hours under the sun and manage its own air supply while doing it. These explanations are not mutually exclusive, and the evidence is genuinely mixed, and the argument has been running for a century without anyone landing a decisive blow. It is a strange thing to find sitting at the front of your own face, in plain sight, visible in every mirror you have ever looked into. An open question. There is a rule in anthropology about nose shape and climate, and it was noticed more than a century ago. It is usually called Thompson's rule, and the observation itself is simple. Populations with long ancestral histories in cold, dry places tend to have narrower, taller nasal openings. Populations with long histories in hot, humid places tend to have wider ones. The proposed logic is straightforward and rather satisfying. A narrow passage forces air into more contact with warm, wet tissue, which is exactly what you want when the air outside is cold and dry and trying to hurt your lungs, and exactly what you do not need when the air is already warm and already saturated, and the real problem is getting rid of heat. The rule was noticed simply by measuring a great many skulls, long before anyone could test the mechanism or explain it properly, and it has survived a great deal of scrutiny since. It remains one of the very few visible features of the human face that appears to carry a genuine record of weather in it. A study using three-dimensional face scans found that nostril width varies more between populations than chance alone would predict. The work, published in 2017, compared measurements of the nose across people with ancestry from different regions and asked one specific and clever question. Does this feature vary more than the neutral background variation we see across the rest of the genome? For most traits, differences between populations are modest and largely explained by drift, the random wandering that happens when a species spreads across a planet and stops mixing. For nostril width, the researchers found more variation than drift alone could account for, and the pattern lined up with temperature and humidity, rather than with anything else. The reasonable conclusion is that natural selection acted on it, gently, over a long time, which means that the shape of the nose you are breathing through tonight is in some small part a note about the weather in a place you have never been, written into your face by people whose names nobody will ever know. But climate is not the whole story, and the nose may also have been shaped by who found whom attractive. Selection on the nose appears to be real, and yet noses vary far more than any purely functional explanation would require. Straight, curved, wide, narrow, upturned, hooked, flat, high-bridged, broad-tipped, and 1,000 things in between. Sometimes within a single family, sometimes between siblings raised in the same house, breathing exactly the same air. Researchers who work on this generally accept that alongside climate, there was sexual selection, the long, slow effect of preference accumulating over thousands of generations, and simple drift and cultural ideas about beauty that changed every few centuries and left traces anyway. It is not a tidy answer, and people who like tidy answers find it frustrating. It is a better one. Your nose is the result of cold winters and of chance and of somebody a very long time ago in a place with no name yet, finding somebody else's face lovely for no reason that anyone could have written down. The first projecting human nose probably appeared well over 1 million years ago in a species that was learning to walk very long distances. Skulls of Homo erectus show changes around the nasal opening that suggest the beginning of an external, forward-standing nose, rather than the flat opening of everything that came before. Researchers have connected this to the same period in which the body was becoming long-limbed, heat-tolerant, and capable of covering enormous ground in open, dry country under a hard sun. A body that moves for hours in dry heat loses water with every single breath, and a longer nasal passage recaptures some of it on the way out, condensing moisture back onto the lining before it can escape into the air. Over a long day, that adds up to real water, and water was the difference between arriving and not arriving. Whether it was the cause of the change or a happy consequence of it is still debated and may never be settled, but the timing is suggestive. The nose seems to have started growing outward at roughly the moment we started going somewhere. Neanderthals had enormous noses, and for a long time everyone assumed it was for warming, freezing air. The face of a Neanderthal is dominated by the nose. The opening is vast, far larger than ours, and the whole midface is pulled forward around it so that the profile leads with it. The obvious story was cold adaptation. Bigger heater, colder Europe, longer ice age. But when researchers ran three-dimensional models of Neanderthal skulls and simulated the airflow through them, the picture became considerably more complicated. Their conditioning of cold air was in some respects no better than ours, and by some measures, possibly worse. What their noses did allow was a much greater volume of air, moved with much less effort per breath. That fits a body that was heavy, muscular, and metabolically expensive, needing very large amounts of oxygen simply to exist in a cold place, let alone to hunt in one. So perhaps the great Neanderthal nose was not a heater at all. Perhaps it was an air intake, built for an engine considerably bigger than ours. And some of the shape of your own nose may have come from them. Most people with ancestry outside Africa carry a small percentage of Neanderthal DNA, inherited from encounters tens of thousands of years ago that we know almost nothing about. In 2023, researchers examining the genetics of facial shape across a very large sample reported that a particular region of the genome influencing the height of the nose appears to have come from Neanderthals and to have been kept rather than lost. The proposed reason, cautiously stated, is that it may have been useful in colder climates, and that a population arriving from a warm continent could effectively inherit a ready-made adaptation from people who had already spent a few 100,000 years working out how to live there. It is an extraordinary thing to hold in your mind in a dark room. There is a real possibility that some part of the exact shape of your own face is a gift from a different kind of human, handed over somewhere cold, an unimaginable amount of time ago, and kept ever since. A handful of specific genes have been identified that help decide whether your nose is broad or narrow, pointed or blunt. Large studies of facial shape have picked out particular stretches of DNA associated with particular features. Some influence the width of the wings of the nose. Some affect the shape and height of the bridge. Some influence how much the tip points up or down, which is the difference between two faces that people describe entirely differently. They tend to be genes involved in the early formation of cartilage and bone, working quietly in the developing face of an embryo, long before there is anything recognizable to look at. Each one contributes a small amount, and the final result is the sum of many small contributions, plus a great deal of chance and circumstance. This is why children resemble their parents without ever copying them exactly. The nose is not inherited as an object, handed down intact like a piece of furniture. It is inherited as a set of instructions, loosely followed by a process with no interest in the outcome. Almost every baby is born with a small, flat nose, and the face you will end up with does not arrive for decades. Newborn noses are broad, soft, and barely raised at all. This is partly the pressure of birth and partly simple development, because there is not much there yet to raise. The nasal bones are tiny, the cartilage is unformed, and the whole structure grows outward through childhood, accelerates sharply in adolescence, and continues subtly changing for years after that. The nose is one of the very last parts of the face to settle into itself. Look at photographs of anyone at 7, at 17, and at 37, and the eyes are recognizably theirs from the very beginning, unmistakable in every frame, while the nose keeps arriving slowly, changing the whole face around it each time. It is the slowest sentence in the paragraph of a face. It is still being written long after you have left home and started calling yourself finished. Your nose looks larger in old age, but it did not really keep growing. This is one of those observations that everybody has made and almost everybody has explained wrongly. The bone stops growing when you stop growing, and that is the end of it. What happens afterwards is subtler and sadder, and rather more beautiful. The cartilage remains slightly active and can change over decades. The skin loses elasticity. The supporting tissues weaken gradually, and gravity works on a soft structure standing out from a face for 70 or 80 years without a single break, without one night off. The tip descends. The bridge appears longer. It is not growth so much as slow settlement, the way an old house leans towards the ground it has been standing on, which makes an elderly face a kind of record of duration, and makes the nose the part that has been quietly keeping the measurement. Nothing was added to it, just time, applied evenly for a very long while. Men's noses are, on average, larger than women's relative to body size, and there is a proposed reason. Research examining the growth of the face through childhood found that male and female noses track together closely until adolescence and then diverge, with male noses growing larger relative to the rest of the body from that point on. One suggested explanation connects this directly to body composition. Men typically carry more lean muscle mass. Muscle is metabolically demanding. Demanding tissue requires more oxygen, and the nose is the airway that has to deliver it. On this account, the difference is not decorative at all, but respiratory, a simple matter of supplying an engine that got bigger. It is a hypothesis rather than a settled fact, and other factors are certainly involved, including hormones and the same sexual selection that shaped everything else. But it is a nice example of how a feature that everyone assumes is about appearance may turn out on closer inspection to be about breathing. The cartilage in your nose has no blood supply, and it feeds itself by soaking. Most tissue in your body is threaded through with vessels, dense with them, dependent on them minute to minute. Cartilage is not. It is a dense, springy matrix with cells scattered thinly through it, and no plumbing at all. Nutrients arrive by seeping in from the tissue around it, and waste leaves the same way, slowly, patiently, without any pump involved. This is why cartilage is so tough and so light, and why it survives a lifetime of pressure and bending without complaint. It is also exactly why it heals so badly. A cut in skin closes within days because blood arrives immediately, carrying everything required and a crew to install it. Damaged cartilage repairs reluctantly, if at all, because its entire delivery system is diffusion, and diffusion does not hurry for anyone. The material at the front of your face is one of the most patient substances in your whole body, and it does not do emergencies. Around 2,500 years ago in India, a surgeon described how to rebuild a nose using skin from the forehead. The text attributed to Sushruta contains instructions for taking a flap of skin, keeping it attached at one edge so that it retains its blood supply, rotating it down over the gap, and shaping it into a nose. The technique is essentially the same one used today, and modern surgeons still call it the Indian method, which is a remarkable thing for a technique to be called 2,500 years later. The reason it existed in the first place is a great deal less pleasant than the achievement. In that world, as in many others across history, cutting off the nose was a recognized punishment, applied for adultery and for crime and for being on the wrong side of a war, precisely because it was survivable and permanently, publicly visible for the rest of a life. Where there is a punishment that leaves people alive and marked, there will eventually be somebody quietly working out how to undo it. The oldest reconstructive surgery we know of exists because of one of the oldest kinds of cruelty. The Byzantine Empire used the removal of a nose as a political tool, and once it went badly wrong. It was called rhinocopia, and the logic behind it was cold and perfectly clear. An emperor who kills a rival makes a martyr and a legend, but an emperor who mutilates one makes him ineligible, because a ruler was expected to be physically unblemished, and a disfigured man could not sit on the throne. So the deposed were disfigured and exiled rather than executed, and everyone considered this both merciful and final. In the year 695, an emperor named Justinian II was deposed, had his nose cut off, and was sent away to the far edge of the empire, which everybody understood to be the end of the matter and the end of him. It was not. He spent a decade in exile, gathered allies and an army, came back, and took the throne again, wearing by some accounts a prosthetic nose made of precious metal while he did it. His nickname afterwards was Rhinotmetus, the nose slit. He remains the only person in recorded history to have lost an empire, lost a nose, and then got the empire back anyway. In 16th century Italy, a professor of surgery published a book on rebuilding noses from the skin of the arm. His name was Gaspare Tagliacozzi, and his method required the patient's upper arm to be strapped up against their face for weeks, while a flap of skin grew into place and established a blood supply. It sounds unbearable, and it was, and people accepted it anyway and queued for it. He published in 1597, illustrated in detail. He was mocked in verse by people who thought the whole idea was absurd. The church was uneasy about it, on the grounds that a man ought perhaps to keep the face he was given. And the demand was enormous regardless, because Europe at that exact moment was living through the first great wave of syphilis. And one of the things advanced syphilis could do was destroy the soft tissue and the bone of the nose entirely. Surgery arrives when there are finally enough people who need it to make the mockery worth enduring. And there were. For roughly 3 centuries, the missing nose was one of the most recognizable sights in Europe, and people organized around it. Prosthetic noses were made of silver, of copper, of painted wax, tied on with ribbon or held in place by a pair of spectacles built for the purpose. There are accounts of social clubs in 18th century Britain formed by and for people who had lost theirs, meeting regularly, reportedly with a certain amount of dark good humor about the whole situation. It is very easy to tell this story only as horror, and it is horror, but it is worth telling the other half of it too. A great many people lost a piece of their face to a disease that nobody understood and nobody could treat, and were stared at in every street they walked down for the rest of their lives, and did not hide indoors. They made appointments. They ordered silver from craftsmen. They found each other and had dinner together, and presumably made jokes. Human beings are extraordinarily good at building a life out of whatever is left over. Today, reshaping the nose is among the most commonly performed cosmetic operations in the world. It is a small operation on a small structure, and it is unusually difficult, and surgeons who specialize in it will say so without being asked. Everything in a nose is connected to everything else, so a change in one place appears in 3 others. The skin over it is thin enough to reveal any imperfection underneath. Millimeters are visible from across a room. It is regarded as one of the least forgiving procedures in the entire field, and it stays popular anyway, year after year, decade after decade, across cultures with wildly different ideas about what a nose is supposed to look like. The interesting fact here is not really the surgery. It is what the surgery says about the nose. Of all the things a human face contains, this is the one that people most often want changed. It sits in the middle of everything. It cannot be hidden by an expression. It is the one feature you cannot escape in any photograph ever taken of you. An extremely small number of people are born without a nose at all. The condition is called arynia, and it is so rare that the entire medical literature of the last century contains only a small number of documented cases worldwide. The external nose fails to form, and in many cases, the internal nasal passages fail with it, which affects breathing and smell profoundly and requires serious medical care from the first hours of life onward. What is worth saying about it is not the rarity, because rarity on its own is just a number. It is that the children born with it grow up and go to school and are photographed on their birthdays and are loved completely and become people with opinions and jobs and favorite songs, and that the families involved have spent years patiently explaining to strangers that a particular arrangement of a face is not a requirement for a life. It is the smallest possible reminder of the largest possible fact about being human. The wall between your two nostrils is almost certainly crooked, and this is completely normal. Studies examining the septum find that some degree of deviation is present in a large majority of people, on the order of 4 out of 5, which makes the perfectly straight septum the genuinely unusual case, and the crooked one the rule. Most of these deviations cause no symptoms whatsoever, and are discovered only when somebody happens to look, usually for another reason entirely. They arise from growth, from the process of being born, from small knocks in childhood that nobody remembers and nobody cried about. So the two halves of your nose are almost certainly not the same size, have never been the same size, and it has never once mattered to anyone. It is a good thing to know about bodies in general, and worth carrying out of tonight. A great deal of what would look wrong on a diagram is simply what everybody has. Ancient statues are missing their noses so consistently that it has its own explanation, and part of it is simple physics. Walk through any museum of classical sculpture and you notice it within about a minute. Noses gone. Everywhere. Room after room of them. Some of that is deliberate. Images defaced during periods when the old gods became unwelcome and a face was worth attacking. But a great deal of it is pure geometry. The nose is the part of a stone face that projects furthest from the mass of the block, and it is supported by the thinnest neck of material holding it on. Every time a statue falls, or is moved, or is dropped, or is jostled in the back of a cart across 1,000 years of trade and looting and rescue, the nose is the part that meets the floor first. The eyes survive because they are recessed and protected. The nose is out in front, with nothing in front of it. It is exactly the same reason it breaks on living faces. In marble and in flesh, it is the part standing furthest forward, and the world arrives at it first. In more than one culture, the traditional way to greet someone is to touch noses, and it means something specific. In the Maori Hongi, two people press noses and foreheads together and share a breath, and the meaning is not affection, but recognition, an exchange that marks the visitor as no longer a stranger and brings them inside. Among Inuit peoples, the greeting, sometimes casually described as an Eskimo kiss, involves pressing the nose to the skin and breathing in. And it is used with family and with children, and it is closer to a way of taking someone in than to a kiss at all. There are related customs across parts of the Pacific, of Arabia, of Mongolia, arrived at independently by people who never met. It is the same instinct found over and over by different people in different centuries, with no contact between them. When human beings want to know each other properly, and words are not going to be enough, they do not shake hands. They bring their noses together, and they breathe. And so, gently, we arrive back at the surface. Everything we have spent tonight with is happening right now, a few centimeters from your eyes. The air is being warmed. The cilia are moving in their slow waves, the way wind moves over a field. One side is doing more work than the other, and will hand over in a few hours without asking your permission. A thin film of fluid is catching the whole room and quietly disposing of it. Somewhere above all of that, in a patch of tissue the size of a stamp, cells that will be replaced within a month are touching the outside world directly and passing what they find along the shortest road there is to the parts of you that remember and feel. You do not need to hold on to any of it. Not the numbers, not the names. Not the emperors or the astronomers or the bacteria in the soil after rain. Let the facts settle behind you like pages closing at the end of a long evening. They were never yours to carry. They were only ever company for a few quiet hours. Let the room be still now. Let the bed take your weight properly, all of it. Let your breathing find its own slow speed, in through the nose, out again, unhurried, the same rhythm your body has been keeping since before you had a name for it, and will go on keeping long after tonight has been forgotten. If this kind of quiet science helps you rest, you are welcome to come back whenever the night feels too loud. There will be another calm video waiting when you are ready for it. But for now, let all of it become distant. The air is warm, the work is being done. Nothing needs your attention. Sleep well and good night.